Okay, so I see that we can start. So let's get going. So good morning, everyone, and thanks for joining this very exciting webinar that we have for you on advancing non-road mobility. I think we can go to the next slide. So what is the agenda for the morning? We are starting around 10 and we have about 90 minutes ahead of us. What you can see on the left is, of course, a bit of publicity for the strategic research innovation agenda that we have. This is, of course, a document on which we base most of the webinars that we organize. So I strongly recommend you to have a look at it. So I will give you a short introduction about BEPA and BAT4EU. Then I will give the floor to my colleague Jess, who will give you an overview of the applications that we have dealing with non-road mobility in the strategic research and innovation agenda. Then Michele will take over for the panel. We will have, of course, a Q&A session, so feel free to indicate your questions in the chat. And then when our colleague Walter Eisermans will be back, we will be giving back the floor to Walter for the concluding remark. So if we go to the next slide. Yes, this is me. I guess you know me by now, but I'm Fabrice Tassin from Emicor. I'm also the Secretary General of the association running the partnership. And we can go to the next slide. For those of you who may not be very familiar with the partnership, I guess there are two acronyms that you should understand, and maybe I can give you a short introduction to that. BAT4EU, BAT4EU, which you can see in the middle of the slide. This is actually the name of the European Commission's co-program partnership that we have on batteries. That is programmed between 21 and 27 with a funding of about 925 million euro that is channeled to collaborative research across a wide range of TRL. This co-program partnership, they are the new name of the what was called before public-private partnership. And in public-private partnership, you understand that the public part, this is of course the European Commission, but the private part, which you have on the left of the slide, this is the legal non-profit association, which has to co-pilot with the Commission the partnership. And in our case, the name of this legal entity is BEPA. So BAT4EU, this is the name of the instrument, if I may say, and BEPA is the name of the legal entity that is co-piloting the instrument. And in the frame of BEPA, what do? We have more than 230 members right now coming from different parts of the value chain. We also have made the commitment to the European Commission that we would match the amount of funding that they put on the table, and actually we do more than matching. And of course, we organize various events, and we also have as a mission to facilitate the innovation uptake. If I go to the next slide. Maybe quickly before we give the floor to Jess, I want to remind you of the vision and the objectives that we have, what we want to do via BEPA and via BAT4EU. And we know that we are just one piece of the puzzle, obviously, is that we want to contribute to a competitive and sustainable European battery value chain for mobility, but also for stationary application. And how do we do that? We do that with three main objectives. One is to support the development of technologies in battery materials, the cell design and the manufacturing and the recycling. And actually what you can see on the right of the slide, this is the circular battery value chain. And the more green the arrows, the more active we are in the field. So basically you see that we are starting from the raw materials, not the mining, but the refining of them. Then we move to the active materials. Then we move to the battery cell. And when it comes to the pack and to the module and the pack and then the integration into applications, we have limited activity because we, of course, partner with other partnerships that are also funded by the Commission and who have that as a mission. The second objective that we have is, of course, to do everything we can to accelerate innovation and the deployment of the innovation onto the market for mobility. And the third objective is about the same, but having in mind that we also need a lot of stationary energy storage if we want to have a a more robust and a cleaner grid in the future for Europe. And we can go to the next slide. And on the next slide, this is me about to give the floor to Jess, our policy officer. So Jess, the floor is now on your side. Thank you so much.
Thank you, Fabrice. Yeah, my name is Jesse Terry. I'm a policy officer in BEPA, the Batteries European Partnership Association. Hopefully, many of you here already know me from the working groups, which is where we developed the SRIA, which I will explain now. So what is the SRIA? It's the Strategic Research and Innovation Agenda, which is meant to guide research and innovation priorities along the European battery value chain. It's a BAT4EU publication, meaning it was created by us in BEPA plus our colleagues in the European Commission, advising the future research and innovation actions and funding allocation for batteries in Europe through Horizon Europe. It was created in our working groups, that is joint working groups between BEPA and Batteries Europe, which gathered over 500 experts across 6 different working groups across the battery value chain, who discussed and gave their opinions and expertise on priority innovations still needed to be developed through Horizon Europe funding. And an important note, this is the second SRIA, so it was an updated version published in February this year. The first one was published in 2021, and we updated it to reflect the current state of the art and the changes in the past 4 years, taking into account the ongoing funded projects and funded topics already done through Horizon Europe to make sure that we stay looking forward and keep up to date with what's going on and the results we're hearing about. So with that, a little bit of backgrounds, I will go more into detail about the mobility chapter in the SRIA, which we'll be focusing in on today. So the first strategic action is high performance, cost efficient, and safe by design battery systems, which is broken into 2 subcategories. That is advanced thermal management technologies for batteries in harsh use and extreme conditions. The main point here is that improvements are still needed for newer chemistries, which is especially true for non-road applications, which we'll hear more about later today. And this can be done by developing novel cooling solutions and cooling agents to improve performance under sustained fast charge cycles, which is also especially important for these non-road applications. And this can inform users of optimal usage and charging profiles. On the other side, we have high performance and cost-efficient safe by design batteries to increase performance through multi-type cell arrangements, enhanced integration, which for example could be cell to airframe for aviation, or interfaces to other systems like hydrogen and fuel cells for these hybrid systems, which are also a common option for the non-road machinery. Fast charging capability is crucial for several mobility applications, especially non-road. And finally, lightweight materials and efficient pack integration to fit into things like ships and trains and aircraft. And a main point between both of these is that safety considerations are a main cost driver for several applications, which again is especially true for the non-road applications, which we'll hear more about later. So the second strategic action is cloud-based battery management for multi-application integration. Cloud-connected battery management system enabling advanced algorithms and models to improve safety and functionality. And this, of course, is important to be connected to the battery passport. And regarding the multi-application side, cloud aggregation of battery assets for multiple units or vehicles can provide fleet management capabilities. This can include different levels of sensorization depending on transport modes and use cases, decentralization of the battery management system, design for battery packs, and cloud data storage for optimizing performance. And of course, an important part of this will be the cybersecurity factor, for the cloud-based data for energy management system or battery management system for those developed and operated in the European Union. And on the right, you can see just a basic graphic of a kind of concept of the cloud battery management system, starting with data generation from the battery system, to sensing, to data collection and the Internet of Things, to being stored in the cloud, analyzed, and then given a data visualization for optimized usage profiles and feedback on the battery. This picture is not from our Syria, but it's taken from a research paper for a concept of a cloud-based battery management system. So moving to the next one, I have accelerated multi-physical and virtual testing and developments. So this is for testing and accelerating the testing of validation and the verification stage of battery cell testing, aiming to shorten development time and costs of battery cells and systems. This can also help to standardize battery system testing and validation approaches. This mixes physical and virtual testing methods and aims to simplify test strategies, reduce the number and complexity of battery cell testing. And what you can see on the right is coming just last month from Porsche Consulting, which is a graph demonstrating the difference in the cell and validation time between the vehicle and the cell. And this is basically meant to visualize how much longer the cell testing takes than the vehicle testing. So the cell testing has to start a lot earlier than the vehicle testing, which increases the complexity and lead time of system developments. And basically, this topic is meant to cut down that validation and verification testing time for the battery cell to reduce complexity a little bit and bring these development times a bit closer together and more in sync. And an important note that you can see in the blue there is that we have a topic which is addressing this, ready to go for Work Program 2025 in Horizon Europe, called Accelerated Multi-Physical and Virtual Testing for Battery Aging, Reliability, and Safety Evaluation. So we're excited to see the projects that will come out of this in the next work program of 2025. So moving forward to the fourth strategic action, which is a more generic one called Demonstrations for Mobility Applications. And there's a bit more background information on this given in the SRIA, but basically these are high TRL actions meant to bring concepts and demonstrate them to prove effectiveness and bring into the markets. So there are different examples of this for each transport mode. I've focused here on aviation, rail, and waterborne. And these points are just main points needed for each application and are not necessarily to be done all together in one project, but hopefully to help get the idea of where these systems are at and what is needed there. So for aviation, we have safe, lightweight, airworthy battery modules and packs to be integrated in relevant electric architectures, interfacing with electric conversion systems. And also going back to the thermal management, we have cooling systems in the BMS, for the BMS and in-cell sensors. And one of the main points here is the high C rates, so high discharge rates needed for power boosting. Going towards rail, we have batteries that are being used as onboard energy storage systems. Important notes here is improved charging times, regenerative braking capability, ability to power the train for short to mid distances, especially in the case of a main power failure. And virtual demonstrations could be done and could be paired with other demonstrations like hydrogen or other hybrid systems like that. On the waterborne side, can have battery swapping, especially for inland shipping and short distance ferries. It's important to have corrosion resistant materials, and that needs to be able to withstand continuous discharge close to peak power. Reliability and safety are crucial here, especially for thermal management, avoiding thermal runaway and avoiding, obviously, water getting into the battery. Direct liquid cooling, including partial or full immersion, could be done. And once again, fast charging, especially at ports and remote locations, is important. So part of the SRIA, part of each chapter is a timeline for the strategic actions. So what you can see here is that timeline, which includes on the blue side what has already been done, and on the green side what I've just explained and where we see it on the timeline for Horizon Europe work programs. So for the first one, you can see we've already done next generation technologies for high performance and safe by design battery systems for transport and mobility. There's already topics that kind of feed into this done in 2023. And we foresee thermal management needed a little bit more urgently. So in 2026, going from TRL 4 to 6, and then high performance, cost efficient, safe by design batteries. A little bit higher TRL going from 5 to 7, starting in 2027. So for the battery management system strategic action, you can see we already have 2 topics funded there, one in 2023 and one in 2024. And we foresee the cloud-based BMS starting from TRL 4 going to TRL 6, also starting in 2027. For the accelerated multiphysical and virtual testing, we have one similar topic focusing on digitalization of battery testing already underway starting in 2023. And for this next iteration, as I explained earlier, we have already on the table in work program 2025, hoping to finish at TRL 7. And it will be coming out in work program 2025, which means by the time the grant agreement gets done and the project is actually starting, it will be early 2026, or if not middle 2026. So this one is right on time with what we planned in the SRIA. And finally, we have our demonstration topics. We didn't separate them out here for the sake of the timeline because they're all kind of grouped together, but this would of course be a higher TRL finishing at TRL 7 at least. And yeah, it could be done anywhere in the last 2 years of Horizon Europe, but we've put here to be done in work program 2027, which means starting in 2028. And in the blue, you can see already 2 similar topics we've already done, including size and weight reduction of cell packaging and battery systems, which was this year in September. And on the other side, development of technical and business solutions to optimize circularity, resilience, and sustainability of the European battery value chain, which was also a call already completed in the last work program. Of course, these technology readiness levels are kind of generalized, so there might be some exceptions to this, but this is the basic idea of how we foresee this sector of the battery value chain in the last couple of years of Horizon Europe. So to conclude, I would also like to introduce the Forward Survey. It's a BEPA consultation initiative to identify challenges and solutions for the 10th R&I Framework Program that is commonly known as FP10. So as you know, we're approaching the next framework program as Horizon Europe is coming to its conclusion at the end of 2027. And the next framework program is coming up, so far dubbed FP10, which will continue to shape the future of the European battery value chain. So it's important moments where expertise and insights of everyone who has been involved can share their experience and influence strategic direction, funding priorities, and innovation focus for the coming years. This helps us to build a compelling case to help to lobby for improvements in the next framework program, especially for more battery funding, of course. It is a guiding recipe for other EU support mechanisms, not only Horizon Europe, and in general can address broadening challenges in the battery community. So what we're looking for specifically is to identify challenges. So you can share challenges that you've observed in the European battery value chain and in the funding ecosystem. It's going to be broad or specific, high level, low level, covering technical and economic, environmental, strategic, business, and organizational aspects. And if possible, suggest solutions. So you can propose solutions that innovation provides to these challenges and highlight how innovation can move the sector forward. How can you do this? So we have launched a survey on EU Survey. You can get it from the QR code here, or also you can find it on our website as well. It's open until the 24th of December, so if you need a Christmas Eve activity for the whole family, you are welcome to fill in our survey here. So please complete the sheet with your identified challenges and proposed solutions, and we'd also appreciate it greatly if you could share it with colleagues and peers in the field to get as much feedback as we can. We will then write a report about the contributions we've received, and it will help us quite a lot with Framework Program 10. So any feedback here is greatly appreciated. And on that note, hopefully everyone has had time to scan this QR code. Again, you can also find it on our website. And with that, I've concluded my parts. And we can now move into our panel discussion on advancing non-road mobility, batteries for rail, aviation, and waterborne transports. And I'll now give the floor over to our moderator, Michele De Gennaro.
So thank you, Jess. Thank you, Fabrice. I trust that you can hear me well. Good morning, everyone. My name is Michele De Gennaro, and I have the pleasure to moderate the second part of this Monday morning webinar on batteries. Many of you might already know me. I am head of competence unit at AT, Austrian Institute of Technology. My unit is the Electric Vehicle Technology Competence Unit, where I manage for the Institute the portfolio of research projects in the electrification of surface and aerial vehicle. But in my capacity as head of unit, I also cover a few other positions. First of which I'm glad to be the president since last March of the ARPA, the European Automotive Research Partner Association. I am member of the scientific advisory body of the Clean Aviation Joint Undertaking, but most importantly for this webinar, I am researcher of the working group number 5 of Batteries Europe, in charge of mobility application. And within the work group 5 in Batteries Europe, we do develop and we do discuss the roadmap for advancing batteries in terms of quantitative KPIs, objective scopes of activities for all types of application, from cars, so to light-duty vehicles to heavy-duty vehicles, no-road mobile machinery, airborne application, waterborne application, and rail application. And this is the focus of the webinar this morning, the no-road mobilities, airborne, waterborne, and rail. I would invite the 3 guest speakers that we have today to activate the webcam. We have 1 guest speaker per each application. So I see Mosen, you activate the webcam. Giuseppe, please, if you can, and Xavier. And I'm glad to introduce the speaker for this morning. I would start with Giuseppe. Giuseppe, you are representing the airborne application, I guess. Can you please introduce yourself?
Thank you. Good morning, everybody. Thank you, Michele, and thank you, Jess and Fabrice. Yes, our involvement in research for aeronautics concerns especially the regional sector. and we work in research investigating the possibility to have a sort of hybridization on the aircraft, especially in our sector, in order to reach the target for the zero emission. Zero emission is quite simply far from what we are discovering that it's possible to achieve on the part of the aircraft around 100 and below 100 passengers in 1,000 nautical miles. This is the more or less the part of the sector investigated for the regional application. And we have considered the opportunity to equip batteries to perform hybridization of propulsion and systems, but only we discovered that it's possible only partially due to the high impact of the battery in terms of weight on the aircraft. But it is not only the new unique challenge that we have on the aircraft. A lot of implication will come about the energy, power, and so on. So
Thank
I
you.
could continue a lot, but I don't want
Yeah.
to.
Thank you, Giuseppe. I don't want to spoil too much of the content of the next slides. So this was just a quick personal interaction. Giuseppe is working for Leonardo Aircraft. By the way, that's quite relevant. I would hand over then to Xavier. Xavier, you are representing in this webinar the rail application. Can you just spend 30 seconds introducing yourself?
Okay, thank you. Good morning, everybody. So my name is Xavier Larrea. I am the Rail Energy System Platform in CAF, which is a Spanish rail manufacturer. So already more than 10 years involved with energy storage systems and associated power electronics. We have more than 15 years experience integrating this kind of systems in trains. We started our path with tramways, and now we are currently putting our focus in regional battery trains, in which, generally speaking, the industry has a target to jump from 100-kilometer range to 200 kilometer in the short term.
Thank you, Xavier. And last but not least, Mosen, you are representing here the Waterborne application. Please introduce yourself.
Thank you very much, Michael. Hello, everyone. Good morning. My name is Mohsen Akbarzadeh. I have a background in battery systems, specialized in thermal management of the batteries. I work at Flanders Make, a strategic research center for manufacturing industry based in Belgium, where we work on many applications in the context of future industry, including electrification of transport systems, where we actively work on road transport and marine transport systems. We do have multiple large European projects in the context of Waterborne sector, and I'm glad to be here and share some insights about batteries in this sector.
Thank you, Mosen. I think we are done with this very quick introduction and roundtable. For the webinar of today, we have prepared 3 questions that I would like to listen the opinion of the 3 of you on these 3 questions. I kindly ask you to provide an answer in a couple of minutes in a way that we stay in time. And I would say that we can deep dive first. We can deep dive in the first question. So next slide, please. And as a first question concerning batteries for road mobility, I would like to hear from each of you, what's your perspective in the current and future role of batteries within your specific application? So how batteries as a techno brick can serve the decarbonization of your specific application, and what technological advancement do you see as essential for achieving this objective? So we can go through the same order. Giuseppe, from the airborne side, what can you tell us about this interesting topic?
Yeah, as introduced before, a different kind of characteristic are considered on the aircraft, especially the one most important for us is the gravimetrical density of the energy. We have started in the 2018 considering a possible application on the aircraft, as anticipated before, also with the most challenging characteristic for a scene, up to 2000 watt-hour per kilogram in this time frame considered. As anticipated, is not possible to replace completely the powering from jet fuel to the battery. So today, the most demanding scenario that we investigate for the energy gravimetrical density is 500 watt-hour per kilograms. And what we would like to understand is the possible application of this in terms of cells and pack. As we have understood, the packaging efficiencies is more related to the integration of this battery on the aircraft. So, in our opinion, is as we have understood, is different to take some cells, package and install on the aircraft, or package directly this cell on the aircraft, performing the integration. So clearly, we would like to reach the most demanding level of efficiency about that. Clearly, strong impact comes also from the power demand that we need on the aircraft. Consider that for an aircraft of the level of a possible ATR 72, just an example, we are speaking of 770 passenger, more or less. Also to reach the 50% of the utilization, we need 1 megawatt per site. So we are speaking to reach 50% of 1 megawatt for each engine, okay, to power with the batteries. Other challenge clearly it's related to the volumetric characteristics of energy density and power density, but not only. Time to recharge for the aircraft on ground during turnaround time, for our case, is the order of the 20 minutes from a mission and another, from a route and another. And as you know, to recharge sort of level of 1 megawatt hour, more or less, should needed some consideration about how to recharge it, if it's possible to recharge by ground device, or replace boxes in the aircraft directly to avoid to lose more time. We have seen also that charge and discharge characteristic of the battery is considered in terms of C rate, most related to the time to recharge. But we would like to also to understand how to manage it in terms of energy to recharge in the battery for the capacity stored, and characteristic of the ground station to recharge in terms of power related to the C rate. Also, life cycle and cost is a challenge that we have considered. And an important point for the integration, it's related not only to the characteristic to achieve, but also for what concerns aircraft safety, temperature, and the environmental condition in general in the environment around the battery in which it are installed.
Thanks, Giuseppe, for this comprehensive response. So if I can summarize, energy, power, and secret infrastructure, thermal and safety. So quite a long list of desiderata. Flying at a flight level that is achievable. So something in the range of 500 watt-hours a kilogram. We all know that with 2000 watt-hour a kilogram, it would be a different world, but that's most likely not something that we can envisage for our foreseeable future. Thanks a lot for this answer.
If I may, Michele, sorry,
Sure.
just to conclude, this is just the forecast for a possible entry into service in the 2035. But considering that in the paramount of the application of the research, there is also the demonstration phase, and should be identified also some level of this characteristic for 2030 in order to perform TRL-6 evaluation on the aircraft.
Sure, we want to put batteries in air. That's quite important. I would hand over to Xavier. Xavier, same question to you, but pitched on rail application.
Okay, so about the perspective, I will start saying that generally speaking, trains are probably one of the early adopters of the electrification. The catenary solution, you know, the catenary is the overhead line that supplies electricity to the trains. So the catenary has already more than 100 years. However, there are almost more than 20% of the rail lines in Europe that there is no catenary. So these lines are not electrified. And currently these trains are circulating, they are diesel powered. So in general, the rail industry, we are mainly talking about regional battery trains. And the good news are that the new battery powered trains are already an alternative to the diesel powered trains because they are more competitive, at least in some cases, at least in some lines. In those cases, we can have a positive business case if we compare the whole life cycle cost of a battery train in front of a diesel train. We have to take into account that the rail sector is a very long-term business. Typically, the trains are manufactured to circulate for 30 years. It is true that the upfront cost of a battery train can be slightly higher than a diesel one, but the return of the investment is achieved in few years. So that's why we can say that it's already a competitive vehicle. About the necessary technological advancements to achieve the net zero emission, well, here the question is how to reduce the carbon footprint of the battery powered trains. If we focus again on the batteries as a key subsystem of such vehicles, in my opinion, we can highlight two main factors that are impacting on reducing the carbon footprint. The first one is the energy density or the gravimetric energy density. So in the future, if the batteries can store more energy per kilo per kg, this would mean using less raw materials for the same amount of energy. So less energy in manufacturing, raw materials, processes. So generally speaking, less CO2 emissions. And the other factor is the cyclability or durability of the batteries. As we are in a 30 years life cycle industry, it's widely accepted that the batteries of a train should be replaced several times. So if the durability of the batteries increases, we could reduce the quantity of those replacements. So we could reduce also the carbon footprint emission, and we could also reduce the LCC costs generally. So basically, the good news here are that reducing the carbon footprint is also good for the environment, but also good. It's also a profitable business. They are both in the direction.
Thank you, Xavier. It's interesting to listen how 20% of the railroad still needs to be electrified, although railroads quite an early mover in electrification, and indeed increasing the gravimetric energy density or decreasing per watt hour the intense use of raw materials is definitely a common objective, I would say, across the industry. You also touched on the replacement of batteries, so refurbishment of existing rolling stock. I think that this is something that we can also touch later, and it's an element that is reflected in the upcoming Batteries Europe roadmap. Handing over to Mosen, also here, same question to you, pitching on the specs of the waterborne applications.
Yeah. Okay. With the advancements in the battery industry in the past 10 years, especially in energy density improvements, safety improvements, and cost reduction, batteries have become an economical solution for maritime application. And we see that the number of ships with batteries on board are increasing exponentially. Currently, I think there are around 300 ships using batteries, which are using battery or under construction. And this is still, I think, less than 1% of the global fleet. So there is a lot of room here to deploy batteries on board the vessels, especially in Europe. Maritime industry accounts for around 15% of the emissions. And we see a lot of interest in the industry to use batteries, especially with the new concepts like autonomous vessels. There is a big interest in using batteries. And in terms of applications, I would say that for maritime includes a lot of ship types with different requirements. Currently, batteries are used to power the small-sized vessels and short-distance ships, like ferries, like boats, some kind of inland ships. But when it comes to large vessels, powering the ship with battery is not feasible, but battery can be used as a hybrid system to provide applications like peak shaving, load leveling, zero emission during port stay, auxiliary power supply, and all these applications can contribute to the improving the system performance and efficiency and reducing the fuel consumption and emissions. And the technological advancements that are needed, I would say cost is very important in maritime industry. The cost of battery system in ships is 2 times more expensive than EV. This is due to the high safety requirements in this sector, due to the harsh environment. Also, if something, let's say safety issue happens, it can have catastrophic consequences. There are limited escape options in the ships. Therefore, safety is very important. Also, to reduce the cost, I think new battery technologies, either new cell technologies, which are cheaper, and also new system designs are important to reduce the cost of the batteries. Of course, increasing the cycle life and enhancing the energy density are also important parameters for the future of the maritime batteries.
Thank you, Mosen. So reducing emission where it matters through hybrid propulsion, so in near coast operation of ships, if I get it right.
Yes.
As well as improving the environmentally friendliness of a sector that is the most transport environmentally friendly sector per kilogram of payload. I think that's something that needs to be highlighted in the maritime transport.
Of course, yes.
We can move to the next slide. In the next slide, I think that some of you have already spoiled part of the answer for the next question. Based on the elements that have been discussed, that you brought under discussion, can you pitch towards some quantitative key performance indicator that you consider to be the most critical for batteries to meet the demand of your specific application? Giuseppe, you already mentioned the 500 watt-hour per kilogram, which I imagine it's a target that has to be achieved in between cell and pack levels. Let's put it this way. But can you also mention some other quantitative KPIs which are really relevant, really crucial to make aircraft fly hybrid?
Yeah, what is for sure, the same quantity of energy per kilograms is needed also in terms of volumetric density, efficiency for sure, and the same density in terms of volume and mass for the power is something that is useful. The packaging efficiency too, but we have understood that is something for the aircraft that is more useful to consider in terms of direct application for the integration of the aircraft, since we have limited the space. We have limited the space to store. Also, in agreement with the passenger seating and cabin capability. An important KPI, as said before, is the C rate that we have understood more related to time, inverse of time, but we need to understand in the turnaround available on the aircraft the relation between the energy and the power from the ground station. Other consideration is related to the cost and the capability to reuse the battery in other form at the end of life, just to reduce this cost.
Thank you, thank you, Giuseppe. Thank you for this. Thank you for this overview. So it's about energy density, it's about power density, coherently with what we said before. It's a C rate compatible with turnaround time of the aircraft. I think that we do have some quantitative KPIs in the upcoming revision of the roadmap about that. I'm going to memory something like between 20% and 95% in 20 minutes. That's what we target for. Is there anything quantitative that we can mention on safety, being safety so critical for airborne application?
Yes, some considerations, as said before, about the environmental condition and the position respect to the passenger on board. There are some consideration on the aircraft in our evaluation related to possible installation in the fuselage close to the wardrobe and with the passenger seating, but we have understood that for problem or fire and evacuation could be problematic. So we have investigated also some possible installation in the zone of the aircraft out of the cabin, but there are characteristic issues related to temperature and pressures. This is the reason why I mentioned it before during the flight of the aircraft, but not only. Yeah.
Thank you, Giuseppe. So environmental condition and weight imbalance of the aircraft. Thanks. Moving to Xavier, same question to you. You mentioned the increase of gravimetric and volumetric energy density as a means to achieving carbon neutrality by using less raw materials. Is there any quantitative KPI that you would like to mention that you think particularly relevant towards rail application?
Well, first of all, we have to understand the current situation of the market. the regional trains, regional battery trains, we can currently offer a range of roughly 100 kilometer. But the market requirements are increasing, and the new target of the industry is to achieve 200 kilometer range. So coming back to the quantitative key performance indicators, of course, energy density is there. Installing heavy batteries in a train is a hard task in terms of weight and volume. We have to respect also some axle load limitations, and there's many volume restrictions. So today, I would say a rail battery is roughly about 100 watt-hour kg, roughly. Mm-hmm. So hard to establish a new figure, but I would say that 150 or, of course, 200 is better. Would be a very nice figure to achieve this target of 200 kilometer range.
Okay. Maintaining or reducing costs compared to actual baseline. That's also quite challenging. So
yeah, it's always a trade-off between energy density, cost, durability, fast charging. So we always need to find a compromise. We have to improve all these factors without penalizing any other one. So yeah. Another one would be the cost, initial cost, and the TCO cost, or durability, also linked with durability. As I told before, in a heavy-duty application like a train, the cyclability of the batteries is crucial to reduce the quantity of the battery replacements in 30 years lifetime. And I would like to add another one, which is fast charging. Today, only very few chemistries can support the fast charging rates that allow charging the batteries in few minutes, so minimizing the operational impact in the passenger transport. It is true that in some cases where the train operates under the catenary lines, it is possible to recharge the batteries for a while, allowing the train to be ready to operate with fully charged batteries in the next catenary free section. But there are also some other sections or lines, for example, from point A to B, and return. So there's only a single opportunity to charge the train in the station for a few minutes. Let's say close to 5 minutes, not more. And then the train should restart the journey. So for those cases, it's very important to have a fast charging capability in the batteries.
Thank you, Xavier. Very interesting. And I mean, speaking about intermittent charging in different section of the rail which are served or not served by electrification, I would say that also poses quite some challenges in terms of battery management system and the management of all these charge and discharge cycles across the operation over the day of the train. Mohsen, moving to you, which KPI do you see to be the most relevant for Waterborne? Maybe also expanding on the specific environmental and corrosive condition that we do experience on a Waterborne application.
Yes, that's true. So this brings kind of strict safety requirements in marine sector, and accordingly, the cost of the battery systems will be high due to these high safety requirements. The cost of the battery includes both capex and opex, and for the capex, I would say that the cost of the battery cell in marine is more expensive than EV because the demand is less than EV. Shipbuilders will receive the cells more expensive than EV makers. This is one aspect. And the other one is that the system design, as you said, to these strict safety issues, there is a need for different safety components, safety measures, which increases the cost of the battery system. And as I mentioned, it's around 2 times of the EV battery pack. In terms of the operational cost, also the design life of the battery for ship applications is at least 10 years, sometimes 15 years, sometimes 20 years. And accordingly, the degradation cost, the operational cost of the batteries is also very important for the maritime batteries. Regarding other KPIs, I would say energy density is important, especially volumetric energy density, because there are typically, let's say, less space for batteries on board the vessels. considering the importance of the redundancy in the marine, so that we need some backup batteries on board the vessels. Sometimes ships have 2 battery rooms. One of them is just the backup. And this brings issues with regards to the available space and weight. So the more and the higher the energy density, of course, the better. And efficiency is also important. There are a lot of losses in the battery systems. We need a very well designed system and power electronic components. Also, cooling in batteries is important. So there is a lot of power needed for the cooling system. And accordingly, I would say the losses or the system efficiency is another important KPI for maritime batteries.
Thank you, Mosen. It's interesting to see an application where volumetric energy density seems to be more prominent compared to gravimetric energy density, and of course, the safety, corrosive environment, thermals, and so on and so forth. Thank you. We have one last question that I would like to pose to you, and then we can go through the Q&A. So the last question is, what suggestion do you have for the next remote program? We know that we are now towards looking at the end of Horizon Europe, which has accompanied us between 2021 and 2027. We already have a glance on what is coming up in the next 3 years, basically what Jess planned before. But looking at the FP10, what do you see to be most important to be highlighted to support the delivery and deployment of clean technology in your sector, strengthening the European competitiveness, keeping in mind that European competitiveness will be the leitmotif of the FP10. So what can you tell us about it, Giuseppe, in the airborne sector?
Yeah, what concern the competitiveness of the scenario that could be afforded for the Europe, our suggestion is related to the life cycle of the battery. We understand that the high rate of the degradation of the battery once used by the aeronautical sector could be something that it really impact the use of such kind of technology. So in order to mitigate this impact, one of the possible approach should be to study technology of the battery to use in order to enlarge life cycle of it, reusing it once degraded by the aeronautical sector in other field, or use technology with which it is built, reuse again in other manner. Another consideration about the battery, especially for the competitiveness, especially for the aviation, if it's possible to rethink the battery, not considering it as something to install into the aircraft like a system, but use the material already equipping on the aircraft, like the structure or something like that, in order to perform battery function. I know that it's more related to safety consideration and so on, but could be a possible approach to take into account. I understand also that it's such kind of application. It's something that it's not so simple for the Navy. I mean, just for corrosion or something like that. Another important point is what level of quantity of the energy storage into the battery could be used with respect to the whole capacity of the battery in order to avoid the hysteresis effect. Clearly, in order to reduce the impact on the aircraft, we would like to use the higher percentage of the energy stored into. But how to join this need with the needs to have fast recharge and high level low current to use.
Thanks, Giuseppe. So enlarging the usable battery energy window as also a means to increase the gravimetric performance of the battery itself. And you touched on multifunctionalities. So using batteries as structural element of the airframe. So eventually using cells as a part of the structure. That's also quite an interesting topic on which there are a few research actions which are moving on, and we do expect this to see subject for the next framework program. Xavier, looking at the FP10, where do you see batteries in the FP10 for rail application?
Well, I would say that there's not single and simple answer, but let's put it in an adequate context. I think firstly we have to acknowledge that the entire rail industry is not and will not be very representative in terms of battery consumption comparing with other industries, like especially automotive, as you know. But on the other hand, the requirements are also very different. And I think that rail industry needs can have a huge commonality with some other heavy-duty sectors, like marine, for instance. And that if we join our forces and group our efforts, we can still build a specialized ecosystem, starting from the cell level to the vehicle integration, and taking into account intermediate steps like modules, packs, power electronics, and so. So my message or my suggestion would be to somehow join the forces to strengthen our competitiveness in those niche sectors that are being electrified, where European companies are already well positioned. Rail is an example. Rail is quite European. Most of the demand is European, and the manufacturers are most of them Europeans. So I think if we work together and join the forces, because we have similar requirements, similar market characteristics, and so we will increase the volume. We could find some local production, local customers, and advance in that direction.
Thanks, Xavier, and also thanks for highlighting one element that is never stressed too much: the ability of Europe and the capability that we have, but we have to push harder to have a systemic approach to mobility and defend what are our European leading industry. You mentioned the rail industry, Europe to be a leader in the rail industry, but the same is in aeronautics. Europe makes the best civil aircraft, period, in the world. So, and while batteries, we know that unfortunately is not yet a European-led industry, the vehicle industry is yet a European-led industry, and we have to capitalize on this. Mohsen, last but not least on you, what do you see in FP10 relevant for waterborne application and batteries?
Okay. I think on one hand, we see the progress in the new battery cells that are improved in terms of energy density, safety, and so on. But on the other hand, we can do a lot of work at the system level to bring more batteries on board the ships. Especially, I would say scalability is important there because there are many types of ships with different operational requirements and different size of the vessels. So scalable solutions allows us to address the challenge that we have here, and also scalability allows to bring new cell technologies to the marine transport systems easily. Also, I think in the system design, modularity is quite important, again, due to the long cycle life of the batteries that is required for maritime. With such solutions, we can reduce the maintenance cost, operational cost, and I think these are some important aspects. Of course, safety, thermal management are definitely benefits that can be brought to the maritime sector by better system design. And I think another important aspect here is the charging infrastructure, because in maritime it's not easy to have chargers everywhere. And also large vessels require a lot of power that can put a lot of stress on the grid in the port. So availability, accessibility of the chargers, and again, at the system level, I would like to mention the containerized solutions, the swappable batteries, especially for the inland shipping, that can be an innovative solution. Especially these can, when we have problem with the cycle life of the batteries, if we use a swappable battery, I think then we don't have this problem anymore. And last but not least, I would like to mention about a large feasibility study that we need in the maritime sector to see which chemistries, which battery systems are better for which type of application. As mentioned, there are variety of applications, and even one ship operating in, for example, south of Europe might have different requirements that the same ship in north of Europe due to differences in the, let's say, weather temperature, water temperature, and so on. And also standardization is important in this sector. So I think these are quite interesting topics for the next framework.
Thank you, Mosen. Thank you for mentioning the containerized solution. I think that maritime has something to teach to many in terms of modularization. So, and also thanks for mentioning again the infrastructure that we're seeing, that is a topic that has been mentioned in a slightly different angle from all the three applications, and of course is a common topic with the automotive. Especially I believe that there are many synergies that airborne, rail, and waterborne can exploit with the heavy duty electrification. Just thinking to the work that the heavy duty road industry is doing on the megawatt charger and on this standard, that it's quite relevant also for other modes of transport. This was the last element in our discussion today. So thank you to three of you for this intervention. I would again remind Giuseppe, would you like to add anything?
Yes, just a question. But do you think that we could complete your table maybe in the link shared, and we will receive a return about your forecast of the BEPA Association or something like that?
I'm not sure I got the question. Maybe this is a question.
Sorry, I'll try to formulate in other form. I see you have shared a link to be filled with some consideration.
That's the questionnaire. That's the questionnaire. Yes, I think it's in the chat. Yeah.
So,
and I see that there are some people which get an error message.
So if we individuate two scenario or time frame, do you think that could be also supplied to us some indication about the parameter that we have mentioned? It's possible to do it?
I would revert this question to to Walter later. But anyway, what I wanted to remind is that concerning the parameters and KPI, there is an update of, as I mentioned at the beginning, of the Batteries Euro roadmap that is going to be published in January, February, beginning of next year. And I believe that many of the elements that have been discussed today are somehow reflected in this update of the roadmap, and therefore will be, of course, the calls and the topics where applicants are free to build up their own proposal. Giuseppe,
sorry
we are
for
going
the
to touch
interruption.
we're going to touch on this on the Q&A. I would hand over now to Jess and Wouter. I think that Wouter and me weren't connected, and still we have the Q&A at the end of after the Wouter intervention, and we still we remain here to eventually respond from questions from the audience. Wouter, just back to you.
Thank you, Michele. I can take it just over from here, but I think it's good if we just before going to the concluding remarks, just dive into straight to the Q&A, so we can look at what the questions of the people that have joined us online. Very interesting discussion. Thank you a lot, and also a lot of questions coming in. One question for Moshen regarding the maritime batteries. How will the cost breakdown of the battery modules will be shaping maritime batteries for the next 10 years? So how do you think that costs will develop for these modular batteries?
Yeah, I think it's quite difficult to give a concrete answer, but I think with the innovations in the modularity, in the better system design, I think now the difference with the let's say road transport is that, as I mentioned, maritime batteries are 2 times more expensive. This is at the system level, not only modules. It includes cell module and the battery system, including battery pack, battery rack, and etc. I think this number will reduce, of course, but on the other hand, we see a lot of progress in the EV industry. So I would say now, if it is like 2 times more expensive, maybe in the future it can be reduced to 1.5, and a bit difficult to give a concrete answer because the developments in the battery industry is very, as you know, there are rapid developments there, and the prediction for future is a bit difficult, but definitely there will be a reduction in the cost of the batteries in this sector.
We also discussed a lot of different indicators that are important and the trade-offs. So people are now asking what are the 2 key ones for each sector? If you have to cut it down to 2 indicators that we need to fix in the battery systems, what should we do, Xavier? Sorry to put you on the spot as first, so the other 2 have a little bit more time, but.
Okay, well, it's hard to just limit it to 2, but of course, cost should be there. Cost should be there, and maybe the second one is energy density. Yeah, just simple answer, but I think this is the most important ones will be those ones.
And for the aviation sector, Giuseppe?
I suppose the one mentioned by Javier is the same also for the aviation. Probably another one, considering that it's not possible, as you have mentioned it before, for the train sector, the recharge time. It's not possible for us, so we need the time to recharge. That is also restricting. So I need to enlarge to 3 at least.
Nice. And Moshen, whether you have a special one rather than those 3, or?
No, I agree with Javier about the cost and energy density, because, for example, in terms of cycle life, if the battery, we cannot use the full depth of discharge for certain cycles that is needed in the maritime sector, we can reduce that depth of discharge. We can cope with the cycle life requirements, but the battery will be oversized. This increases the cost of the battery. Or about the safety, we can make safe battery systems by adding a lot of components to make sure that there is no safety issue, which at the end increases the cost of the battery system. So cost, and on the other hand, I think energy density and also the charging capabilities, I think, are important KPIs. But if we want to limit to 2, I would say that cost and energy density.
Yeah. Then another question that's relating to these KPIs is to have we set for every sector a KPI for energy density, just like we did for power density and for the C rate that we wished. I think that in the last KPI table of the Batteries Europe one, we also looked at energy density. I think then in the it will be part of the roadmap update, but Michele, you're a little bit
yes.
more
No,
on top of that.
I can confirm. In the roadmap update that we are publishing beginning of the new year, we are updating the quantitative KPI. And we are also providing them in a kind of textual form, highlighting and pitching on elements which are more or less relevant for the different application, including road application, because the roadmap also includes road application, which are today willingly not represented. On parallel, within the Batteries Europe Secretariat, we are maintaining a living document, which is the KPI Excel list, where we are updating the KPIs for the different application. We have one Excel list that is transversal to the application, and then we have one Excel list per each application, which pitch on specificity. And this is a living document that we are keeping up to date every 6 months. The Secretariat come back to us and ask to revise and eventually update the KPI list. So indeed, these are all elements which are available, but needs also to be always maintained based on the outcome of the work that is undergoing under the other working group, especially how the different electrochemistry are advancing.
I will post a link to the KPI table in the chat so people can have a look as well. We touched upon also on safety, and safety is always safety is the key, one of the key factors, but it's also huge in terms of a subject to cover. So we already slightly touched upon it. Like Moshin, you said, for maritime, it's very important that we look at the weather elements and the weathering of the systems. But are there special safety issues on the per application that we might not consider if we coming from batteries from road transport? Giuseppe, is there something that we really need to take on board in this big safety basket that we need to pay attention more for aviation?
Safety consideration for the aviation imply also the kind of installation and integration of battery. Clearly, depending what kind of installation you perform on the aircraft, you could change the level of integration and the consideration to report. As said before, in example, consider that if the battery could be installed in place of the wardrobe on the cabin, clearly you have to contain the fire problem. So you could indicate also material for the batteries, trying to avoid completely the chemistry. Another point could be related to the safety of the replacement or recharge of it. Okay. Another kind of consideration could be related if you install the battery out of the cabin passenger. So if you put it in the part of the aircraft not conditioned, so you should manage the environment in the box in which installed the battery, and clearly could be related on what type of installation you perform and where.
Yeah.
In example, on ground in the airport, if you put the battery in the lower part of the cabin, you should consider also the position in relation to the truck during the relation and the replacement or. So there is a lot of restriction about the aircraft for safety.
Yeah, exactly. Good. Very interesting to know, and then also, yeah, to continue to develop together in the future. Xavier, for you, on the safety issue, is there something special for the rail application?
Yes, it is. Actually, I think we can have a lot of commonalities with other sectors, like maritime ones that Moshe explained. Yeah, this is because mainly due to a safe evacuation of the passengers. If you compare this with automotive sector, okay. So we have to have a safe evacuation of the passengers if any accident or fire propagation occurs. So, for example, today in the rail battery standards, we cannot have any fire leakage to outside of the battery box for at least 8 hours, in comparison to 5 minutes for some other sectors. Well, so additionally, this extra, let's say, some extra intrinsic safety at cell level can help to reduce the cost of safety levels at pack level. Fire retardants, extra metallic protections, and so. And we also think that the safety requirements will increase in the future. We will need more robust integration, more, let's say, intelligent electronics, maybe adding also some gas sensors to have an early detection of a thermal runaway, and so. So yes, there is a real mindset of that safety should be there, and I think that the threshold will increase in the future.
Okay, yeah, clear. One last question that comes in, and maybe it's for Giuseppe, but also maybe bring in Michele. It's a more longer-term view on aeronautics, is whether non-electrically rechargeable batteries are also seen as an option, aluminium, air, and those kind of newer chemistries. That will be for the next framework program for them to be mature, I think. But are they on the radar at all, or is it just trying to get the current or maybe next generation batteries to work?
No, could you repeat?
Yeah.
I didn't catch completely.
So about the newer kind of chemistry, which are non-electrically rechargeable, aluminum air batteries is one example. They can be very high energy dense.
I suppose such kind of application could be useful also to replace some part of the structure of the aircraft. Clearly, you could keep in place of the battery this structure. So maybe it could be one option to limit the impact of the weight. But the point is that what is the correct environmental condition in which use? Consider that you could use the external structure for the aircraft between range of minus 50 degrees up to plus 50. So it's feasible to use in so different environmental condition the battery. That's the point.
Maybe I can complement concerning new and very exotic chemistries. I'm quite skeptical. At the moment, there are plenty of research projects which are investigating at very low TRL, let's say, non-conventional solution. And I'm not a chemist, but I've worked for a long time with chemists, and with no offense meant to anyone, chemistry is kind of black magic. You really never know exactly where you're gonna landing. So a lot of things are possible on paper. Then when you go in the lab, nothing works. So I would rather focus for the envisageable and foreseeable future on what we can really deliver, and what we can really deliver, the electrochemistries that we can really deliver as a European battery value chain ecosystem are semi-solid state batteries and maybe solid state batteries, but semi-solid state batteries which do use a blend of liquid electrolyte and jet polymer electrolyte that are performing enough. And I would put the attention on this one. Concerning very new electrochemistry, I would be very cautious in making any prediction, because there are a lot of things that needs to be assessed, demonstrated. I would like also to add one more thing on the safety aspect that you mentioned, Wouter, and then I conclude. Safety, it's a culture, and it's a culture that needs to be adapted to the specificity on the single application. What do we need in Europe in terms of safety is also to acquire experience, acquire operational hours, acquire data. And we do start, and aeronautics is a clear example, we do start with shooting at very high safety requirements, but as time come in, as flight hours come in, as operational hours come in for a ship or for a train, we can understand better how these chemistry or this technology operates on long term, and maybe at a certain point also decide to relax safety, to go more towards active safety instead of passive safety. And at the same time, we also need, as European battery ecosystem, new experimental capabilities which are capable of reproducing in lab, in controlled environment conditions that have still to come in vehicle level. And I do see here, as we gain momentum as an industry, a little bit of a kind of downward path. Things are becoming easier as we gather experience. So there is kind of glimpse of optimism ahead of us.
Yeah, that's a hopeful message to
Yeah.
end on, Michele. I think that's very good. I want to thank all of you for your very good insights from the ground. I think both for people active in their own field or just looking at what their neighbors are doing, and also for the people who are more concentrated on the batteries. I think it was all lots of valuable things for everybody in there. So thank you a lot for taking the time this morning to enlighten us. Rest for me to thank all the people who are listening. Some questions that are still coming in, we can try to address them later. If you subscribe to our newsletter, you can get the presentation by Jesse, and then maybe we can add some Q&A questions there. One of the questions, for example, is like Jesse showed that we have this demonstrator on TRL5. What are the chemistries? Again, just like Michele mentioned, they are either trying to create full solid-state systems or almost solid-state or very advanced battery generation 3B battery systems. Those will be up until TRL5 in the upcoming years. So we'll keep a close look on them, see what comes out of it, and then we'll also need to fund up the next follow-up as well. And I really want to thank you also for your takeaways for the next framework program. It shows that Europe has a lot to do, but also a lot of potential to be competitive in these industries. But also that there's a lot of things that we need to tackle on the battery level and the battery system level to make that happen. The systemic use of batteries in the aircraft, how to integrate them in such a way. That's also an issue that some people even in the road sector are looking at. It will be crucial to continue to fund that. And of course, cheaper, better, more performing batteries that charge faster. We need to work on that with the entire battery value chain, all the way from the people who need to integrate them in the applications to the people doing the black magic and doing the mining to take the materials off the ground. So also for the battery value chain, there's a lot to do. So I want to thank everybody who joined this now third deep dive webinar on the battery EU strategic research and innovation agenda. There will be more to come in the next year. We'll keep you updated when we get there. I think topics like advanced materials and what's next there are still on the agenda. So we'll definitely look out for that. And for those people that I don't address before then, wish you a merry holiday season and take some time to as everybody in the battery results, recharge your batteries and come back fresh in the new year. So thank you all, and thanks again to all the speakers. Goodbye.
Thank you.
Thank you
Goodbye.
too. Thank you too. Bye bye.